Hello everyone, welcome to my YouTube channel. Today we are going to solve the Magic Hack-the-Box machine. First of all, I'll start with the Nmap port scanning. So the port is this, and Nmap all ports will make output all ports. So we are scanning every TCP port from 1 through 65535. So we can find that port 22 and 80 are open. So I'm going to do map default script version detection and output target tip and port 2280 and 10. So we can find that port 22 OpenSSH and port 80 Apache Web Server is open. So the title looks to be Magic Portfolio, so I'm going to check this 10. So there looks to be multiple images, and the so it appears that we can upload images on this website after logging in. And at this stage, I'm going to perform the web enumeration. So Gobuster and word list and web content, 50 thread, output, Gobuster txt. So we can find information here. So login.php says status 200. It says 200 means OK and the requested resource exists and was returned successfully. And if we look into the images folder, it says 301 moved permanently. This often means Apache is redirecting this endpoint to images endpoint. And if we look into the upload, this is 302, which means bound. A 302 response instructs the browsers to request another URL. The redirect destination is given through the location header later. So this suggests upload.php exists, but unauthenticated users will be redirected to the login.php file. So at this point, we have learned that the application has a login page, login.php. There is a protected upload page like upload.php, and unauthenticated users cannot access the upload functionality because they will be redirected to login.php endpoint. And upload are high value functionality because depending on validation and server configuration, they may allow an attacker to place control files on the server. So at this stage, we can check that whether we can bypass authentication and we can access the upload.php. So first of all, I'm going to navigate to the login.php. So we can find the login page here, and we can intercept this endpoint. Send to repeater, and so we can review this further. So content type is application x www form URL encoded. So this means the body uses key value pairs such as this, and PHPSESSID indicates this website is built with PHP, and this is the PHP session identifier, and the and at this stage we can check whether we can bypass authentication using SQL injection. So first of all, we can check, we can just post like this. It says 200 OK, magic login, wrong username or password. So we can also check with the admin. Also says wrong username or password. And at this stage, I can check or 1 equals to 1, and it is comment for the MySQL, and then we can use this. So with the comment, the password equals to ASD, the part will be commented, and the statement, SQL statement to X for the login will set to true, and then we can check that the location is upload.php. So the flow will be browser submits login form and server returns 302, and browser reads location upload.php and browser request upload.php. And if you also check this, there is no wrong password error, and then so this 302 and location upload.php looks indicating that authentication success. So after the SQL injection, the login endpoint redirects us in the opposite direction, like login PHP to upload.php. So this behavior strongly suggests the application accepted the authentication attempt. The session was marked authenticated. The user was redirected to protected functionality. The database returns a row because the injected condition is true. Since we commented like password and other like statements, and if we also check this with the false statement, or 1 equals 2, and so it also says wrong username or password because since this statement becomes false. So I will also set this again. So false statement remains on login page, but true statement redirects to upload PHP. And at this stage, we can verify whether upload.php is authenticated. Perfect. So if we also check the dev2, memory storage, this value, we can find that this value also equals to this, which is used to authenticate. So now we can upload the file. So we can like, I can duplicate and go to the website. And we can also check that using this PHP session ID, whether we can access the upload.php endpoint as expected. We can use this. So B flag is sending the specified cookie. We will send this, and endpoint is 10.129.3. So we can find that 200 message is expected, which is authenticated. So we understand that username parameter is vulnerable to SQL injection. We can also check this with the SQLmap. This can be 10.3.212 login PHP. And provides the request body, and effective parameter could be username. And using batch, we can use the default choices. SQL map. There should be no data. It says it doesn't seem to be injectable. Interesting. We can also check like uh, this. So the name will be login. Maybe we can level 5, risk 3, and again. We can also use this with the login dot this file from the verb soup, and also level 5, risk 3. So it says that after increasing this, it looks the username, we can check the username is injectable. Username is injectable. And in the meantime, I can check the send the cookie from this. I think we can also verify like post. I think it doesn't need to be post. I can just or it says 200. Okay, and if we check this further, select image to upload, and more. So at this stage we can inspect the how to upload the image at this stage. So we can focus like this part and this part and this part. So the method post means that the browser submits the upload using an HTTP post request. So file data is not normally placed in the URL, but it is sent in the request body. This tells the browser to construct a multi-part request. So the multi-part request can contain normal form fields, file contents, file name metadata, content type metadata, and class input, name, image, type file. The server expects the uploaded file under the parameter image. Therefore, so call request will be image equals to clean.png or image file. So and this verifies that we also have like name submit equals to value upload image while doing curl command. So at this stage we can make like random text file and verify the upload functionality. In the meantime, it says username is vulnerable, the backend DBMS is MySQL, and we can investigate this further. So upload command will be curl, set the cookie, it will be this one, and so we should specify this, otherwise it will consider this as a just like text, not the file we will upload. And submit upload image as we saw from the verb suit, and the endpoint is this, and upload. We can also check this. Sorry, only JPG, JPEG, and PNG files are allowed. This reveals the extension whitelist, JPG, JPEG, and PNG files. The application has now disclosed its validation rule. So we may need to prepare the PNG file. So if we check this, we can potentially download this. PNG test, PNG. I think I cannot check this since it is I can just PNG free image just random PNG file from the website, and I can use this. So file clean PNG. So it is PNG image data which is expected. So a file name extension is the suffix after the final dot, as you already know. So we will upload this curl this ID again, image clean.png that we will going to upload, submit upload image as we saw in the verb suit, and this endpoint I can also check it says the file has been uploaded, so I'm going to check where I can find this file. Grab clean png. The clean.png file looks existing in image. Upload clean.png file. And we can also check this file further. Then image uploads clean png. It says OK. It means that the file exists at the URL and Apache web server can access it and the upload path is correct. So we can find the content type is image/png. It indicates that the file is being served as a PNG. This is expected for the baseline file. At this stage, I'm going to check whether I can upload the malicious PHP shell for pretending as the image file. So first of all, I'm going to clean Nmap shell. I'm going to use the double extension file, which is like PHP, PNG. So when it comes to PHP, the PHP handler can match this. When it comes to PNG extension, so it will be allowed. So the vulnerability exists because the upload application and Apache may interpret the same file differently. Handler and PHP image file. Apache may have a PHP handler rule that matches PHP anywhere in the file name. So this creates an interpretation mismatch. Application sees an image, but Apache sees executable PHP. So we can also look into information about Apache set handler application PHP. And files match directive limits the scope of the enclosed directives by file name, and it accepts a regular expression. So we can check that whether it also can act as a PHP handler. So what I'm going to inject is echo and so it will it will read the CMD parameter from the URL and execute it as a system command and print the result. So you can also check by web share. So this looks to be PHP script. And we can try uploading this in case it can be recognized as the image file. This one will be we will set the cookie image web share php png. I think submit is this. And upload PHP. If we check the result, it is not uploading as expected, I guess. So I can file clean png and file png test png djpg file web share. Maybe I can check this. It is not bound. I can try uploading this again and check now. It is still not bound. Interesting. I can remove web share now and cp php png file. So I can add the echo command again. It also recognizes as PNG file at this stage, so I hope we can upload this. So if I check the message again, it says it has been uploaded, which is what we want, and we can run curl g. It says place the supply data in the URL query string, and the data will be id command, so we expect this will be return the result of the id command. it says binary output can mess up, something like this. You can use strings to check this better. Perfect. So we can bind the result of the ID, and currently we can find that we need to get into the www-data shell. And what I'm going to do is I'll set the listener, and I'll run the reverse shell command to take this. So I can go to the ref shell. I'll use this 114 and 4444, and this will be something like this. And I will encode this because the reverse shell command contains special shell and URL characters. So to reduce quoting problems, we will encode this with base64. Base64 and single line result. So this looks to be the reverse shell that we are interested. We will also copy and we'll decode this here. So it will be like echo and then base64 decode bash. So it will decode, and then the decoded command will be passed into bash for the execution. So we can take the reverse shell as expected, and I will exit this and ID, who am I? So we can elevate the shell at this stage, and can who has bash. Then so we can find that we need to go to desus user and then going to the root. So Python and Control Z. And export, then clear. So we can find that we can navigate to the grab bash desus user and then root user. So what I'm going to do is I will going to use creds hunting GitHub. I will use this script to retrieve the desus user, so I can git clone cd credential and Python 901, and I'll use temp folder and mode. And there looks to be how to use this. I'm going to use this full sweep command. So we can check the root txt file and the name, interest, hi. If we check this, so we can find this password and we first of all we can find DB user I am King Desus. It looks related to the user. That password it could be so this and copy and SSH. Yes, it says permission denied. Maybe I can try su and then the password that I gather. It says authentication failure, so it would not be password for SSH share, but potentially we can navigate this. We can look into this file. Cat. It says the DB name is Magic, DB host is localhost, DB username is Desus, and DB user is I am King Desus. And it says it is also related to MySQL, so I'm going to check whether there is call. It says there is, so we could, and so we can find that and TNLP and MySQL is open with locally, so we can find that it is maybe it can be related to MySQL, and the credential could be Magic, localhost Desus, and I am King Desus. We can use this to access this. And second of all, I can also run the limpias. So down I can also Python. So limpias.sh is important for the enumeration, Linux enumeration. So I can also get In the meantime, I can also run another reverse shell, since limpias could take some time. So it'll be, I can upload this again. And encode the value with the port 445. And I can take the shell. And then what I'm going to do is I'd also like to check regarding this information further. And you can find the MySQL version. But it says the comment MySQL is not found. So so we can find that no MySQL executable is found at this stage. Then we can find whether there is any MySQL related file. ls grab MySQL like this. It says there is MySQL upgrade, MySQL admin, MySQL analyze, and what I want to check is MySQL dump. So MySQL dump can perform retrieving the application data and look for useful credentials. So if MySQL is absent, credentials have not been disproven. So if MySQL is absent, we can check for related MySQL utilities, and we can find MySQL dump exists, and we can use this to export the data. So I'll run MySQL dump. Jesus is the DB username, and flag P prompts interactively for the password, and magic. This is for the DB name, and if the password is prompted, I can use this. So we can find that insert into admin Jesus this one. So potentially we can check this. So must be run from the terminals. It means that I need to do elevate the shell. And then the password, I can use this. perfect. Who am I? ID. I can get the Desus shell as expected, and we can find sudo this may not run sudo magic, and maybe we can check for Limpia's information at this stage. We can wait. So if we review this further, so we can find that if we review this, there is the bin.sys4 file which is unknown SUID binary. It is root users and the Desus is inside users group, so we can run this. So we can read this at this stage. Clear. I believe we can use strings. So it says hardware info lshw fdisk cat, and this part we can review this further. So if we review this, the critical string is lshw. So if we check what lshw, where this is, it is user bin lshw, but it says that it is relative path, not the absolute path. So we can potentially use path hijacking to make our own malicious lshw script and run this and get to the root shell. So what I'm going to do is I'll navigate to this temp folder and create the bake lshw file. So either copy bin bash it to root bash and set ownership and this will be run with the root user, and we have enabled the SUID bit. So this process, this will be run by the root user who is the owner of this binary. So it is set as like, if we run this, we can get to the root shell. and make this executable, and we will export the temp first in the path, but we can also use like path temp and run this. So either temporary puts temp first in the command search path, and either runs the SUID binary, so we can run this. And if we check this, there should be root bash, and not to drop the effective ID, we can set p flag, then ID, who am I. So we can get the root user with this process. And if we also check cd temp ls root bash, so as this princess4 will be run as the root user, the permission has been set for 755 and the owner and the group will be set to root seamlessly, so we can get the root share. So I hope this video is helpful, and see you in the next video.